So let's take a look at quadratic equations. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, so these are just real numbers. Alright, and b or c, or b and c can both be equal to 0, but a cannot be equal to 0, meaning you at least have to have this x squared term to have a quadratic equation. So some examples, I'm just going to write some numbers in. Something like this: 2x squared plus 3x minus 1 equals 0. That's a quadratic equation. You may just have the first term, maybe x squared, and then you don't have the middle term. So x squared plus 1 equals 0. That's a quadratic equation. Or you may have the first term and the second term, but not have the constant term. Alright. Also, your quadratic equation may not be set equal to 0 to start with, but that doesn't mean you can't set it equal to 0 if you need to. So it could be x squared equals 3x minus 5. Okay, and usually if we're trying to solve for x in an equation like this, we're trying to figure out when the equation is equal to 0. So what you'd want to do is move all of your terms to one side of the equation. I usually, if I have a choice and I have terms on both sides of the equation, I try to move everything to one side where the x squared or the first term will be positive, because usually if we're solving the quadratic equation, most of the methods prefer that the first term be positive. Not all, but most. So what I would do on one like this, if I was trying to solve for x, would be trying to figure out what would make the equation equal to 0. So I'd move these other two terms over. So it'd be minus 3x plus 5 equals 0. So when you move things across the equal sign, you just change the positive or negative signs. Okay. So that's just some examples of a quadratic equation. Now the first method that we're going to go over to solve quadratic equations is by factoring. Alright, to solve quadratic equations by factoring, we have to use something called the zero product principle. And the reason it's called the zero product principle is because if you have a product of two terms or two factors, I'm going to call the first one A and the second one B. So if I have A times B equals 0, then either A equals 0 or B equals 0. And so what you do, if you have something factored set equal to 0, you set each factor equal to 0 and then solve if you have to. Okay, for example, let's say, and I'll start out with a pretty straightforward example. Let's say that I had x plus 1 times x minus 2 equals 0. So I didn't have to factor on this one. I was given the quadratic equation in factored form. So if I needed to solve for x, I want to know what would make this left side of the equation equal to 0. Since I have a product, I can apply the zero product principle and say x plus 1 equals 0 and x minus 2 equals 0. Alright, once I've set up those two linear equations, now I can solve the equation by just solving the linear equation like we have before. Subtract 1 from both sides on this one, and so I'll get x equals -1. Add 2 to both sides on this one, and I get x equals 2. So the solution set is -1, 2. These are the two numbers that will make this quadratic equation equal to 0. So if you wanted to, if you multiply this back out by foiling, you could plug, once you do that, if you plug in a -1 or you plug in a 2, your equation will be equal to 0. Okay? Most of the time, you're not given everything in factored form like that. Most of the time, you will have to factor. Now, there are a lot of different methods of factoring. It really depends on the way that you learn. I've heard a method called the tic-tac-toe method. I've heard the method that I usually use is called the trial and error method. And there's probably 3 or 4 different other methods out there. And how you know how to factor is fine. Okay, so just use whatever method that you've been taught. Now let's say that I wanted to solve this quadratic equation by factoring. Let's say that I had 8x squared minus 4x equals 0. So you see, I don't have all 3 terms. I just have the first term of the quadratic equation, that's the x squared term, and the second term, the x to the first term. Whenever you just have the first 2 terms, the way that you factor is by factoring out the greatest common factor. So I need to say, okay, what's the largest number I can divide into 8 and 4? That would be 4. And I have to either take x squared or x to the first. We always have to take the smallest power when you factor out. So I'm going to factor out a x to the first. Alright, then you draw a set of parentheses and you say, okay, what times 4x gives you 8x squared? That would be 2x. And then I didn't factor a negative out or anything, so I'll have just minus. And then I say, what times 4x gives me 4x? That's 1. Alright, and then you could always check by multiplying that back in and making sure you get 8x squared minus 4x equals 0. After you have this thing factored, then you set each factor equal to 0. So 4x equals 0 and 2x minus 1 equals 0. So to solve this first equation here, you divide both sides by 4 and you get x equals 0. To solve the second equation, add 1 to both sides and you get 2x equals 1. So you get x equals 1/2. So the solution set is 0, 1/2. Alright, now if you took and plugged those back in, you would get 0 equals 0. You could plug them in after you factored if you want to check, or you can plug them in before you factor if you want to check. You will get 0 equals 0. Alright. So that's what you do if you just have the first two terms of the quadratic equation. You always just factor out a greatest common factor. Now, most of the time, not all the time, but most of the time, if you want to solve by factoring, you'll have all three terms. And then that goes back to, how were you taught to factor? So let's say that I had 4x squared plus 14x equals 8. Alright, so the first thing that you have to do to solve by factoring is to make sure that everything is on the same side of the equation. If it's not, you need to move it all over and set it equal to 0. The zero product principle doesn't work if you have it set to a constant. It has to be set equal to 0. So if I move my 8 over, I'll have 4x squared plus 14x minus 8 equals 0. Alright, and so now what I'm going to do is I'm going to factor this using the trial and error method. And the way that you do that, you first split this number up, the 4x squared. You either split it up into 4x and x, or you split it up into 2x and 2x. So I'm going to first try to split this up 2x and 2x. Alright, and if I try every way that I know how to factor this using 2x and 2x and it doesn't work out, then I'll go back and I'll try to work it out using 4x and 1x. Okay. The next thing you do is you take this last number here and you write down the factors. The ways you can multiply two numbers together and get a negative 8. So 1 and 8, 2 and 4, those are the numbers I can multiply together and get an 8. Now if I want it to be a negative, one of them has to be negative and one of them has to be positive. Okay, so I'm going to have to put a plus after one of these and a minus after the other. I don't know which one, so I'm just going to make the first one plus and the second one minus. Alright, now I want a positive 14x in the middle. So since I want such a large positive number, I'm going to put the larger number here in this spot so that when I multiply it by 2x, I'll get a large positive number. So I'm going to try to put my 8 right here, and I'm going to try to put my 1 here. Now if this doesn't work, then I can reverse the numbers. I can also try 2 and 4 and reverse the numbers. And then if all that doesn't work, I'll go back and I'll use 4x and 1x and start over. But I need to check and see if I factored correctly. The way you do that is by multiplying it back out. So I'll get 4x squared, then I'll get minus 16x, then I'll get plus 2x, and then minus 8. So combine these two like terms, and you can see I have the right number part in the middle. I just don't have the sign right. I want a plus 14x, not a minus 14x. When that happens, just either switch where you have the 1 and the 8, or the easiest thing to do is just switch the positive and negative. I'm going to make this one negative and make this one positive, and that should fix everything. because when I multiply 2x times a positive 8, I'll get a positive 16x, and then negative 1 times 2x to get me a negative 2x. Alright, so switching the positive and negative signs will change the sign of the middle number. Again, if you don't get the middle number, then try the 2 and the 4. If you still don't get that number, then go back and try 4x and 1x. This is the trial and error method. You just kind of go through all of the possibilities until you factor correctly. Now once you know it's factored correctly, and the way you figure that out is you have to full it back out. Then you set each factor equal to 0 and solve. So you say 2x minus 1 equals 0 and 2x plus 8 equals 0, and solve each equation. Alright, so when I solve this first equation, I get x equals 1/2. When I solve this second equation, I get x equals -4. So my solution set is 1/2 and -4. Alright, I want you to try this one. Actually, I'll give you two. 3x squared minus 9x equals 0, and 2x squared plus x equals 1. Alright, so take a couple minutes and work on those two. Okay, let me work these out for you now. So you need to factor out the greatest common factor, so factor out of 3x. That'll leave you with x minus 3. Now set each factor equal to 0. So 3x equals 0, x minus 3 equals 0. Alright, so I got x equals 0 and x equals 3. So my solution set is 0, 3. Alright, let's try this other quadratic. So you move the positive 1 over to the left side, it'll be a -1. The only way I can break up 2x squared is 2x and x. The only way that you can get a -1 is to multiply, well, using whole numbers, is to multiply 1 and 1, and one of those has to be negative, one has to be positive. I want a plus 1 in the middle, so I'm going to put a plus 1 here, so that whenever I multiply it times this 2x, I can get a positive. Alright, and let's see what happens if I put a -1 here. Alright, so I'm going to check my answer. So we know the first term gives us what we want, and we know the last term for sure gives us what we want. It's just the inner and outer terms, really. So if you want to use a little bit of a shortcut when checking, just multiply the outer terms together and the inner terms together, and those will be like terms, so then put them together. So if you multiply the outer terms, you get a positive 2x. If you multiply the inner terms, you get a negative 1x. So a positive 2x and a negative 1x is a positive 1x. and that is what I wanted. So it means I factored correctly. Alright. Since I know that I factored correctly, now I'm going to come back. I have this thing set equal to 0. I'm going to set each factor equal to 0 and solve. So 2x minus 1 equals 0. X plus 1 equals 0. Alright, so add 1 to both sides. So I'll have 2x equals 1. Divide both sides by 2. Have x equals 1/2. Alright, go to the other linear equation. Have x equals -1. So my solution set is -1 1/2. Okay. Now, one other factoring technique that we run into sometimes when in factoring quadratics is the difference of two squares. And the difference of two squares would be, say, when I had something like x squared minus 4 equals 0. Okay? And so the way that we're taught to factor that is, and why is it called the difference of two squares? It's because the first term is a perfect square, that's something times itself, and the last term is a perfect square, something times itself. And we have a minus between the two, so it's the difference. So the way you factor that is you make two sets of parentheses, and the first set of parentheses, right, which you would have to multiply times itself to give you x squared, that's x. Then you take this last number and write down what you'd have to multiply times itself to give you that 4, that's 2 times 2. And then you simply put a plus with one parentheses and a minus with the other. Okay, and that's how it factors. So then if you want to solve it, you can go down, set each factor equal to 0 and solve. Alright, so you get x equals -2, and you get x equals +2. Alright, so that is how you would solve that by factoring. However, there is another way that you could solve that, which leads us into our next technique for solving quadratic equations, and that is by the square root method. Now, the square root method does not, or the square root property is what your book calls it, it doesn't work for every type of quadratic equation. The square root method will work whenever we have quadratic equations that do not have the middle term or the x term. Okay, that's one type of quadratic equation that it'll work with. For example, this last problem that I just worked, factoring, can also be worked out using the square root property. Alright, and the square root property says that, this is square root property, it says that if we can make the equation x squared equals some number. And if I move this negative 4 over, that'll be a positive 4. If you can ever make an equation x squared equals some number, then that's going to have exactly two solutions, or two answers. Okay? That's going to have the answers x equals the square root of 4 and x equals the negative square root of 4. Now we all know, hopefully, that the square root of 4 is 2. And so the negative and then square root of 4 would be negative 2. Alright, so you get the same two answers, as you should, working this out using the square root property as you would factoring. Now usually the way that I work this out, instead of just writing down this property like this, is I'll say, okay, I've got the x squared by itself and I have the constant on the other side of the equation. Now to make this an x, since it's x squared, I need to take the square root of both sides. Okay? When you take the square root of both sides of an equation, you need to put a plus or minus on the side of the equation that has the constant term. So x is equal to plus or minus the square root of 4. Plus or minus means a positive square root of 4 and a negative square root of 4. Well, we all know that would be plus or minus 2, which means negative 2 and positive 2. So I did the same thing. It's just that that's how you would work that out if you were just thinking about it using square roots like that. Usually that's how we're taught in school. Okay. Now you don't have to be able to take the square root of the number on the right side. For example, let's say that I had 3x squared minus 7 equals 0. Alright, so if I wanted to work this out using the square root property, probably not the best method, but I can work it out using the square root property. I need to first get my x squared by itself. So add 7 to both sides. So I have 3x squared equals 7. Divide both sides by 3. So I have x squared equals 7/3. So now take the square root of both sides, and when you do that you put a plus or minus in front. So x equals plus or minus the square root of 7/3. So that means a positive square root of 7/3 and a negative square root of 7/3. Now I won't lie to you, this isn't the best way to leave your answer. And if this was a homework problem, I doubt that it would take this answer. And it came out to be a fraction because I just made up the problem. But let me show you how to simplify that if you would need to, if you ever had something like that or run into something like that. Well, then what you want to do is you think about when you ever have the square root of a fraction, that's the square root of the numerator over the square root of the denominator. Okay, that's the square root of a fraction. And so what would be wrong with leaving my answer like this is I have a square root in the bottom or in the denominator. So the easiest way to remove that is by multiplying the top and bottom by the square root of 3. So I would have plus or minus. Now when you say a square root times a square root, you multiply what's underneath and keep the radical. So that's going to be square root of 21 over the square root of 3 times the square root of 3 is the square root of 9, or 3. So this is that answer simplified. So the object of this current lesson is not how to simplify radicals and how to simplify the square root of a fraction. But if you ever do run into that, then just know you need to rationalize. So that means that one answer is a positive square root of 21 over 3, and one answer is a negative square root of 21 over 3. So this is the square root property. Now there's one other type of equation where the square root property comes in handy. And that's if you have an equation like this. X minus 3 squared, say, equals 5. So you have one side of the equation that is a perfect square. You say, hold up, that's not a perfect square. Yeah. This is a perfect square because it is x minus 3 times x minus 3. So we have one side of the equation that's kind of already in factored form. It's a perfect square, a binomial that is squared equals any number. And of course I could have minus that number on the left side, or I could have, I can have it on the right side like it is here. Well, the first thing that you have to do to solve the equation, if you want to use the square root property, is to make sure that whatever's being squared is on one side of the equation and the number part, the constant, is on the other side of the equation. Now what we want to do is we want to get rid of this squared. The way that you do that is you take the square root of both sides. Anytime you take the square root of both sides of an equation, you want to put a plus or minus in front of the constant part, or the constant side. So the left side, that gets rid of that radical. So this is now x minus 3 on the left side equals plus or minus square root of 5. Now, regardless of if we can take the square root of this number or not, we have to put a plus or minus in front. Now, when you solve for x now, you have to be very careful. Alright, I'm going to add 3 to both sides, but you would never add 3 behind the plus or minus sign. You never put a plus 3 down there. Put your number when you move it over in front of the plus or minus sign. So pretend there's a 0 there in front of the plus or minus sign if you have to. So now I have x equals, that's positive 3 plus or minus the square root of 5. Alright, that's actually 2 answers. I've just written it as 1, but that's actually x equals 3 plus the square root of 5 and x equals 3 minus the square root of 5. Alright, that's 2 different numbers, 2 different answers. And if my homework or on a test, the way that those answers would be listed would either be 3 plus or minus the square root of 5, or each one separately. I wouldn't think either one is more correct than the other. Alright, let me try another one like that. So let's say that I had x plus 6 squared equals 45. Alright, to solve this using the square root property, first thing I need to do is make sure that whatever's being squared is on one side by itself, and I have the constant on the other side. Now, take the square root of both sides, And when we take the square root of both sides of an equation, we put a plus or minus in front of the real number side. So the square root of the left side will remove the power here. So you have x plus 6 equals plus or minus the square root of 45. Alright, so now to get x by itself, I say minus 6 minus 6. So I have x equals negative 6 plus or minus the square root of 45. And the square root of 45 can be reduced. It can be simplified. Remember, the square root of 45, you can break that up and say that's the square root of 9 times the square root of 5. Because 9 times 5 is 45, and you can take the square root of 9. So that's negative 6 plus or minus 3 square roots of 5. That's two answers. Negative 6 plus 3 square roots of 5 and negative 6 minus 3 square roots of 5. Alright, I'm going to do one more just to show you what happens if you can take the square root of this number and get a whole number. So let's say that I had x minus 2 squared equals 36. Alright, so the first thing I'm going to do is take the square root of both sides. So I have x minus 2 equals plus or minus, and the square root of 36 is 6. Alright, now add 2 to both sides to solve for x. Now make sure you don't put the 2 under the 6. You still have to put it in front of the plus or minus sign. So that's going to be 2 plus or minus 6. And we don't want to leave our answer like this because we have numbers we can work with. Alright, so that's going to be 2 plus 6 and 2 minus 6. That's what plus or minus means. So 2 plus 6 is 8. 2 minus 6 is negative 4. So my two answers would be negative 4 and 8. That's my solution set. Negative 4 and 8. Again, that's going to happen if you can take the square root of the number. Now I'm going to throw you a small curveball here. Let's look at one more example. And we're going to have to use something from that we learned with complex numbers, with imaginary numbers, to work this one out. Alright, so let's say that I had 3x squared plus 12 equals 0. Alright, and you were asked to use the square root property. This won't factor, not right away. It wouldn't factor using the methods that we went over anyway. So if I wanted to use the square root property here, the first thing I need to do is get the x squared term on one side and get the constant term on the other side. So I need to move the constant term over. So I'd have 3x squared equals negative 12. Then I need to get the x squared by itself. So I'd have to divide both sides by 3. So I have x squared equals negative 12 divided by 3 is negative 4. Now if we keep using the same method, the same thing we were doing before, we take the square root of both sides. Now here's where it's just a little different. Now we can still put, or we still put a plus or minus in front, but unless you know about imaginary numbers, which we all do because that's what we did last week, when you take the square root of a negative number, remember the way that you can get rid of this negative under the radical is to put an I in front of the radical. And so for this particular radical, we have the square root of 4. That's going to simplify. Okay, so that's the square root of 4 is 2. So this is plus or minus 2i. So that means my two answers are a negative 2i and a positive 2i. That's plus or minus 2i. So you can get imaginary answers with the square root property. Now you can't get imaginary answers when factoring, like we've been factoring, but you can get imaginary numbers with the square root property. Okay. When do we use the square root property? Whenever we don't have the x term, or we're given something like a binomial squared equals a number, or a binomial squared minus or plus a number equals 0, and you want to solve. You can use the square root property there. Okay. So that's the first two methods for solving quadratic equations.